Energy use and supply has very much been in the headlines in 2022, and there's no reason it will ever stop being a topic of deep focus given the timeline and the scale of the fight we have against rising global temperatures and the rollback of fossil fuels. To discuss what the energy grid of the future could and should look like, we're joined by a global expert on the subject, Professor John Fletcher, Director of the University of New South Wales Digital Grid Futures Institute. Thanks for joining us, Professor. Let's start with a vision of what you see as the biggest changes coming based on the energy supply and delivery networks we use today.
Okay, well, the biggest challenge we have is the electrification of everything. So taking everything we can change from fossil fuel to feeding it using electrical energy generated by renewables. This is going to be a huge undertaking that's going to last for 2 or 3 decades from now. And it presents some great opportunities for engineers and technicians and for business in general. So although it's a big challenge, it offers us some great potential.
I like the way that you're very positive about this. What do you mean by opportunities?
Well, in terms of the engineering of our electrical energy system, if we think about what we have today, we're going to have to duplicate that 3 times over in order to reach our ambitious decarbonisation goals. And that means that we need lots of engineers coming out of universities like UNSW to deliver the innovation and the creativity and the solutions to what is a really complicated challenge.
Well, futurists talk about the Internet of Energy as the net result of a decarbonised world from a city perspective at least. Tell us what they mean by that.
Well, really, it's about using innovative technologies around power converters. Now, power converters sound really technical, but ultimately they allow us to control the flow of energy through our network, which allows us to better utilize that network. At the moment, the electrical energy grid is fairly dumb. There's not a lot of control over how we distribute power. Whereas when we make it smarter and more intelligent, we can use power converters to control that flow of energy through the system and thereby do much more with what we have.
Well, as you mentioned, energy transformation is already well underway. How will new and emerging technologies help us speed up the pace of change? Where is the current research expected to make the biggest gains?
So some of the really innovative solutions we're looking at in the university sector are things like solid state transformers, which are like our traditional transformers, but they are much more intelligent. They are smaller, they're more compact. We don't have to put them by the side of the road. We can put them in manhole covers. So little bits of technology like that can make a really important impact on how we utilize the grid, how we keep the power quality at the level at which we've got used to, and then how we then realize that change from using fossil fuels burnt in large thermal generation stations to things like distributed energy resources, rooftop solar, which is very popular in Australia, making sure that when we utilize that resource, we keep the grid stable and secure.
Let's talk about electric vehicles, because the market penetration of electric vehicles is one obvious and visible example of the movement towards net zero emissions. But from a mass transit perspective, it would seem the grid will need to be completely rethought to cope with massive surge in capacity demand, surely.
I think that's certainly true in terms of the energy demand that we'll place on the network. So if we think about the grid and what it supplies today, to deliver electrified transportation, we have to duplicate that again, just to give you an idea of the scale of the change that we have to put into our grid infrastructure. But I think we have the technologies to deliver that once we realize that's what we have to do. And I think that's part of the challenge, is educating both the public and the politicians and the government what the scale of that investment has to be to deliver that really substantial transition from where we are now to where we want to be with electrifying transportation.
Yeah, and carrying on from that, one of the counter-arguments put forward about moving to 100% renewable energy has been the dangers of relying on intermittent supply. How will this be overcome in the years ahead? And we've seen Australia suffering from this in recent times.
Yes, well, it is a really important part of the issue and the challenge. When we look at something like Snowy 2.0, part of that is delivering the capability of storing large amounts of energy to do more than just day-to-day balancing. At the other end of the timescale, we have battery energy storage, which is a solution that might offer us filling in the gaps between 1 and 2 hours. And then, of course, we have the capability of generating fuels using electrical energy, things like hydrogen and ammonia. And then when we can make fuel, we can then store it and use it on a seasonal variation basis. So again, there are the technologies available to deal with these issues.
Energy storage at scale, big challenge facing the vision of moving towards complete decarbonisation. So what advances do we need to see here?
Well, we need to improve things like fuel cells, which at the moment are still quite inefficient. A fuel cell, when it's operating at its rating, is maybe only 50 or 60% efficient. And what we have there is a very big capability of improving the efficiency. You know, if we go from 50% to 75%, that makes a huge difference to the efficiency of that hydrogen energy cycle. So those are some of the challenges, say, for example, with hydrogen. At the renewables end, again, looking at the rooftop solar market and penetration of rooftop solar within our network, one of the really important things we've been working at recently is making sure all the inverters, which are the technical things that connect rooftop solar to our grid, making sure that they all behave together nicely and don't cause instabilities in the system.
Tell us about the Institute. What are its ambitions to help guide the optimal pathway towards a sustainable future?
Well, the Digital Grid Futures Institute at UNSW is charged with foresighting what we need to do to the grid to make it more sustainable and using less fossil fuel. So some of those interesting issues are to do with controlling the network and keeping it stable. So we're looking not just at doing research there, but also taking our research outcomes and translating them to true impact by delivering new products to new markets, creating jobs and creating wealth for Australia. Because what we do know is there's going to be a huge requirement internationally for all these types of products and services. And if we invest in that area here at UNSW, we can create a pipeline of solutions that then become new companies, new jobs and wealth for the nation as a whole.